Hello. Prior to this video lesson, we were working on evaluating functions. And particularly, if we have a function, no matter what the variable letters are, we should be able to, given any value for the argument, we should be able to put that into the variable, independent variable, and simplify or evaluate. So, straightforward exercise. The first thing that we need to do is make sure that we have the right notation. So I have to make sure to remind myself every time I put a number in a place that used to be a variable, I use parentheses. So that way I can see that right in here that used to be your independent variable, and it matches the argument. Anyway, the next question is, do I know the order of operations? You need to square 4 first and then multiply by -2, not the other way around. And finally we get -28. Now I repeat my mantra, my rosary here, because I have found a solution to the equation which is also a point on the graph. Repeating that over and over is great because it helps reinforce this truth that a lot of times is ignored. It's important to realize how easy it is to find a point on a graph of any function. You just put a number in for the independent variable and it spits out the corresponding y value. Anyway, how do I know I did this right? How do I know I used the order of operations correctly? How do I know I multiplied correctly? The answer is we skip to our technology. We're here. I enter in the function exactly as given, except I change the variables to f of x instead of h of n and x instead of n. And so I put that into the desmos, and then I could actually evaluate f of 4 directly. And desmos says -28, which is the same answer that I got. Even better, you can type in the coordinates 4, comma, f of 4, and it gives you the x, y pair, and it will show you, hey, look, it's a point on the graph, as much as it is a solution to the equation. So here are all the other solutions to the equation, all up along that orange curve. Here's one specific solution to the equation, which I was asked to find. Anyway, the whole purpose of this now is to confirm that I did my calculations correctly, so I will move on to the next. In the next situation, the argument is unknown. It's not x or y or 3 or 5, it's t minus 2. So basically, this is p of t. This would be p of t 2 seconds earlier. So we have to understand, regardless of whether I know this number, I could still do the same mathematics. That is to say, everywhere I see a t, I replace it with t minus 2. Here I apply the distributive property, distribute the 4, and I collect like terms and get 4t minus 13. I repeat the same mantra, t minus 2 comma 4t minus 13 is a solution to the equation and it is a point on the graph. So that's a weird looking point. The point is, pun intended, now I can put in any number I want for t and I can find the points on p of t minus 2 just by putting t in here and putting t in there, replacing it and figuring out what those values are. But why we do this is not important right now. What's important now is that we get the notation and then the skill available to help us to check to make sure that we did our algebra correctly. So that's what this is about. So on my graph you'll see here that I have f of x equals 4x minus 5, so that was the given equation, and then I ask for f of x minus 2. So what I'm asking for there is a new graph that will be related to the original graph, except the x has 2 subtracted to it first. This was my answer, 4x minus 13. I see the green graph representing the green equation, all the solutions to the green equation, and the red graph represents all the solutions to the red equation. I don't see blue anywhere. The reason is because the blue and the green are showing the exact same question. There's the green, and there's the blue, which basically means f of x minus 2 and 4x minus 13 are one and the same. Now finally, I wanted to talk to you about why should we bother checking our answers. I think, an intelligent student would say, I knew this was -28, I didn't need to use technology to check. That's fine, but we don't make mistakes on purpose. That's why they're mistakes. We make mistakes by accident. So let me show you the kind of mistake that an Algebra 2 student in the beginning would probably likely do. Right here, I've actually evaluated the function p of a equals -4 to the 3a power by substituting in -1 for a, and here I got -4 to the -3. Now we haven't studied what it means to have a negative exponent, so I wouldn't expect anybody to know this. But what I would expect is people give it a shot, see what happens. So here I'm just going to take my best guess. Negative becomes a positive. I remember seeing that before. So I just make it positive, and 4 to the 3rd power is 64, so I think that's the right answer. However, if I go to desmos, I put in the equation as written, I substitute -1 for x, and it gives me, not only is it not positive, or it's also not big. It's not a positive number, and it's not even close to 64, so I must have done something wrong. Which means that what I did here, by taking the negative exponent and canceling it, whatever that means, with the negative base, I've actually done something that's not mathematically correct. So I'm teaching myself in the process what I can and cannot do with numbers. Now, to understand this, and don't worry if you don't get this, but the negative exponent really means instead of multiplying repeatedly, we're going to divide repeatedly. So instead of instead of 1 times 4 times 4 times 4, we're going to do 1 divided by 4 divided by 4 divided by 4. And we get -1/64, which in a calculator will round to about here. So I learned a little something about what I know and don't know about negative exponents. Again, this is not going to be on the test about negative exponents, but what is your ability to check your answer and determine if you're right or wrong. So anyway, thanks for watching and have a great day.